The year was 1976, and Detroit diesel ruled the highways with screaming two-strokes. But a quiet new rival from Indiana had other plans. It didn't whine or roar, it growled. And by the end of the decade, it had flipped the diesel world on its head. This is the story of the Cummins NTC-400, the engine that silenced Detroit diesel. Picture a truck stop in 1975. The air vibrated with the distinctive whine of two-stroke Detroit diesels. Chrome stacks belched blue smoke as drivers revved their engines, and that sound meant one thing. You were looking at the kings of the highway. Detroit's Series 71 and 92 engines didn't just dominate trucking, they defined it. These weren't just engines, they were mechanical legends, some of which were forged on World War II battlefields. Most famously, Detroit's 71 series powered everything from military trucks to Navy landing craft. That reputation for reliability later carried to civilian highways, where ruggedness was just as critical. That military heritage translated directly to civilian highways, where reliability under punishment was just as critical. The two-stroke design was pure genius in its simplicity. While four-stroke competitors needed complex valve trains and heavy flywheels, Detroit engines fired on every stroke. This meant twice the power pulses, creating that unmistakable exhaust note and delivering more horsepower from a lighter package. Crucial when payload regulations meant every pound counted. Walk into any truck stop garage in the mid-70s, and you'd find mechanics who could rebuild a Detroit with their eyes closed. The unit injector system was brilliantly modular. Each cylinder had its own injector combining pump and nozzle functions. When one failed, you unbolted it and slapped in a replacement. No specialized tools, no computer diagnostics, just mechanical know-how and a good wrench set. The supercharger was equally bulletproof. That Roots-type blower was gear-driven directly from the timing gears, forcing fresh air through intake ports while scavenging exhaust gases. It was virtually maintenance-free and provided consistent airflow regardless of engine speed, a mechanical marvel that rarely needed attention. The Series 92, introduced in 1974, represented Detroit's most advanced two-stroke technology. Available in V6, 8, 12, and 16 configurations, these engines incorporated improved combustion chambers and more efficient scavenging. The 8V92 became the highway favorite, producing between 350 and 430 horsepower from 736 cubic inches of displacement, depending on configuration and tuning. Detroit's dominance extended beyond just the engines themselves. The company had built an entire ecosystem around their two-stroke technology. Parts were available everywhere, from major truck stops to small-town garages. Service manuals were written in plain English that any mechanic could understand. Training programs ensured that technicians across the country knew how to keep these engines running. The modular design philosophy meant that engines within the same series, like the 6V71 and 8V71, shared many components. This parts commonality kept inventory costs down for dealers and made repairs economical for operators. You could cannibalize a worn-out engine within the same series to keep another one running, and the interchangeability was legendary among mechanics. However, cracks were starting to show in Detroit's armor. The scavenging process that made these engines powerful also meant some fuel inevitably escaped unburned through the exhaust ports. This blow-through was necessary for proper two-stroke operation and was minimized in well-tuned engines, but it still meant some unburned fuel escaped, which was acceptable when diesel was cheap, but problematic when prices began to climb. Additionally, two-strokes consumed more oil than four-strokes, since some oil inevitably entered the combustion chamber during the scavenging process, raising operating costs. The power density that made Detroit engines attractive also created thermal challenges. Because two-stroke designs produced twice as many combustion events, they generated tremendous heat that had to be dissipated. In heavy-haul applications or desert climates, cooling systems worked overtime, and drivers learned to watch temperature gauges religiously. Oil consumption was another characteristic of two-stroke operation. The scavenging process meant some oil inevitably entered the combustion chambers, requiring more frequent oil additions and changes. While this wasn't necessarily a reliability issue, it added to operating costs and maintenance requirements. October of 1973 changed everything. When Egypt and Syria launched a surprise attack on Israel during the Yom Kippur War, the U.S. and its allies backed Israel. In response, Arab oil producers imposed an embargo, and diesel prices skyrocketed.
The Middle East war produced developments all over the world today. The oil-producing countries of the Arab world decided to use their oil as a political weapon. They will reduce oil production by 5% a month until the Israelis withdraw from occupied territories. If the Arab countries keep that pledge, it would reduce their production by almost 50% in 1 year.
Suddenly, fuel that had cost 40 cents per gallon jumped past $1. For an industry built on thin margins, this wasn't just an inconvenience. It was an existential crisis. The embargo hit independent truckers particularly hard. Owner-operators who'd built their businesses around Detroit's reliability found themselves calculating whether they could afford to keep their rigs rolling. Some were forced out of business entirely, while others began desperately seeking ways to stretch every gallon. Truck stops became gathering places for worried drivers, sharing information about fuel prices and availability. CB radio chatter increasingly focused on which routes offered the cheapest diesel and which engines were delivering the best mileage. The romantic image of the independent trucker was giving way to harsh economic reality. The crisis exposed a fundamental weakness in two-stroke technology. The scavenging overlap that made Detroit engines so powerful also made them inherently less efficient than four-stroke alternatives. The supercharger consumed power that wasn't available for propulsion, and the blow-through meant fuel literally went up in smoke. Major trucking companies began implementing fuel conservation programs, training drivers in techniques to maximize efficiency. Speed limits were reduced and route planning became more sophisticated as companies tried to minimize fuel consumption. The days of running wide open were ending, replaced by careful attention to operating economics. But the fuel crisis was just the beginning. The Clean Air Act of 1970 had put the diesel industry on notice that environmental regulations were coming.
The type of air that we have here looks like an industrial or factory town. Actually, we have a very minimal amount of industry and practically nothing that produces stationary pollution. However, our air pollution is generated elsewhere, particularly from automobiles, and blows on the winds into this area.
The EPA was studying diesel emissions and developing standards that would eventually require dramatic reductions in particulate matter and nitrogen oxides. Two-stroke engines faced particular challenges meeting future emissions requirements. That visible smoke characteristic of Detroit diesels under load represented unburned fuel and particulate matter that would be difficult to reduce without fundamental changes to combustion processes. The regulatory environment was also changing. The Motor Carrier Act of 1980 would eventually deregulate the trucking industry, increasing competition and putting even more pressure on operating costs. Forward-thinking operators could see that the industry was moving toward a more competitive environment where efficiency would be crucial for survival. Into this changing landscape stepped Cummins Engine Company from Columbus, Indiana. While Detroit had been perfecting two-stroke technology, Cummins had been quietly developing four-stroke engines that addressed exactly the problems truckers were facing. Cummins had been building diesel engines since 1919, but they'd always been the industrial specialists, powering construction equipment, generators, and marine vessels while Detroit dominated highways. The NTC line represented their calculated assault on Detroit's territory. The development wasn't accidental. Cummins engineers had been studying two-stroke limitations and believed they could offer significant advantages with properly designed four-stroke technology. They weren't trying to outdo Detroit, they were playing an entirely different game. The NTC-400 was part of the Big Cam series, which debuted in 1976 as Cummins answered to changing market demands. At 855 cubic inches and 400 horsepower, it directly challenged Detroit's most popular highway engines. But everything about the engineering approach was different. The name Big Cam referred to the larger camshaft design used to precisely control fuel injection timing and pressure using Cummins' Innovative Pressure Time (PT) system. This wasn't just marketing. The oversized cam provided the mechanical advantage needed to generate the high injection pressures required for efficient combustion. The cam-actuated injection system was more precise than traditional mechanical pumps and could vary timing based on operating conditions. The Big Cam fuel system represented a quantum leap in diesel injection technology. Instead of fixed timing systems, it incorporated variable timing capabilities that optimized fuel delivery based on operating conditions. This was achieved through Cummins' PT injection principle, which maintained constant fuel pressure while varying injection timing and duration. The PT system was elegantly simple in concept, but sophisticated in execution. A gear-driven pump maintained constant fuel pressure to all injectors, while individual injectors controlled timing and duration based on cam profile and engine speed. This allowed for optimal combustion across the entire operating range, something fixed timing systems couldn't achieve. The four-stroke design eliminated the scavenging overlap that caused fuel waste in two-stroke engines. Dedicated intake and exhaust strokes meant complete combustion without blow-through, translating directly to improved efficiency. The engine fired every other revolution, reducing stress on internal components and allowing for longer service intervals. The engine block was a massive iron casting with deep skirt construction extending well below the crankshaft centerline. 7 main bearings supported a forged steel crankshaft, creating a rigid structure designed for highway punishment. The bore and stroke dimensions, 5.5 inches by 6 inches, created a long stroke design that favored torque production over high RPM power. The cylinder heads featured efficient combustion chambers with large valves for improved breathing. The valve train used mechanical lifters and adjustable rocker arms, providing precise valve timing and easy serviceability. The classic pushrod design was robust and proven, favoring long-term reliability over high-revving performance. When drivers first encountered the NTC-400, the difference was immediately apparent. Instead of Detroit's high-pitched whine, the Cummins produced a deep, authoritative growl. It was quieter in the cab, smoother at idle, and delivered power with less drama but more consistency. The throttle response was different too. Detroit engines had a characteristic surge when you hit the accelerator, followed by that distinctive exhaust note climbing in pitch. The Cummins was more linear, building power steadily without the dramatic sound effects. Some drivers missed the theater, but they appreciated the smoothness. Mechanics noticed different characteristics too. The four-stroke design allowed for extended service intervals compared to Detroit two-strokes. The engine could operate longer between oil changes and required less frequent attention to fuel system components. When service was needed, the work was straightforward without requiring specialized Detroit training. The cooling system was designed specifically for sustained highway operation. The NTC-400 generated less waste heat than comparable two-stroke engines, and the cooling system was sized to handle continuous high-load operation without the thermal stress that challenged Detroit engines in demanding applications. Early adopters discovered that the NTC-400 delivered on Cummins' promises. The engine met efficiency claims while providing the reliability highway operators demanded. Word spread through truck stops and CB channels that there was finally a viable alternative to Detroit diesel. The impact hit Detroit diesel like a freight train. Truck manufacturers who'd been exclusively Detroit customers began offering Cummins options. Fleet specifications that had automatically included Detroit engines started listing alternatives. The unthinkable was happening. Detroit's highway monopoly was cracking. The shift wasn't just about new truck sales. Existing Detroit customers began switching when it came time to replace engines or purchase additional equipment. Loyalty that had lasted decades crumbled under economic pressure as operators discovered the Cummins engines delivered better total cost of ownership. Maintenance shops noticed the difference immediately. Engines that had required rebuilds every few 100,000 miles were running much longer before needing major work. The maintenance wasn't just less frequent, it was less complex. Shops didn't need specialized Detroit training to service the Cummins engines effectively. The used truck market began to reflect the shift in engine preference. Many operators sought out trucks equipped with NTC-400s, often placing a premium on these models due to their reputation for improved longevity and economics. This created a feedback loop that reinforced the advantages of Cummins power and made the business case even stronger. Trade publications started featuring comparison tests that consistently favored the NTC-400 for total cost of ownership. Magazines like Overdrive and Commercial Carrier Journal published detailed analyses showing that despite higher initial costs, Cummins engines delivered better long-term economics through reduced fuel and maintenance expenses. Detroit's response included frantic efforts to improve Series 92 fuel economy and maintenance characteristics. Engineers worked on combustion chamber improvements, fuel system refinements, and cooling system enhancements, but they were fighting against fundamental two-stroke limitations. The improvements helped, but couldn't match what Cummins offered with four-stroke design. The company also attempted to address maintenance intensity by improving parts availability and developing better service procedures. However, these efforts couldn't overcome the inherent characteristics of two-stroke operation that required more frequent attention than four-stroke alternatives. Detroit Diesel began developing the Series 60, but it wouldn't arrive until 1987. The decision to develop a four-stroke engine was essentially an admission that Cummins had been right about market direction. Detroit was abandoning the technology that had made them famous to compete with an engine design that Cummins had already perfected. The NTC-400 launched Cummins into highway dominance that would last for decades. The Big Cam platform evolved through multiple generations, Big Cam 2, 3, and 4, each incorporating improvements while maintaining the fundamental advantages that made the original successful. The Big Cam 2, introduced in the early 1980s, refined the original design with improved fuel economy and reduced emissions. The Big Cam 3 added electronic controls for the first time, allowing for more precise fuel delivery and diagnostic capabilities. The Big Cam 4 represented the platform's final evolution, incorporating lessons learned from over a decade of highway service. Today, many Big Cam engines remain in service, testament to the durability Cummins built into the original design. A thriving remanufacturing industry has developed around these engines, with companies offering factory-quality rebuilds of engines now 30 to 40 years old. Many operators prefer remanufactured Big Cams to newer engines because they understand the technology and trust its reliability. The engines developed their own cult following among truckers who appreciated equipment that didn't demand constant attention. These weren't flashy engines that announced their presence. They were workhorses that quietly accumulated miles while delivering consistent economics. Restoration enthusiasts have embraced Big Cam engines as representatives of the golden age of mechanical diesel technology. Before electronic controls and emission systems complicated everything, these engines represented the perfect balance of power, reliability, and serviceability. The NTC-400's success established principles that continue shaping diesel development today. The emphasis on efficiency, extended service intervals, and reduced maintenance requirements became industry standards. Every manufacturer had to match what Cummins achieved or risk losing market share. The engine helped establish the principle that highway engines needed to be efficient and economical to operate, not just powerful and reliable. This shift in priorities influenced the development of all subsequent highway diesel engines and continues to shape the industry today. This wasn't victory through superior marketing or corporate politics. It was earned mile by mile, gallon by gallon, and dollar by dollar. The NTC-400 succeeded because it solved real problems that real truckers faced every day, problems that had been masked by cheap fuel and accepted as the cost of doing business. The impact extended beyond just Cummins' success. The NTC-400 changed how the entire industry thought about engine development, establishing new priorities that continue to influence diesel design today. It proved that truckers would embrace new technology when it delivered clear economic benefits. Did you run one? Work on one? Experience the transition from screaming Jimmies to growling Cummins? Share your stories in the comments. Whether you were behind the wheel, under the hood, or managing the fleet, these engines shaped trucking history. If you want to see how Detroit fought back against the Cummins invasion, check out our other videos on Detroit's engine development. And if you enjoyed this story of how one quiet engine changed everything, hit that like button and subscribe for more diesel history that shaped the industry we know today.